Yeah. Well, yeah. Yeah, that's another.
The link, yeah, so the meeting has the two different ones and I grabbed the wrong one. But I'm gonna get people. Now do you see me or?
Have you ever? Last time you did one.
On the list.
A long time. When I started losing.
You guys should come out and take a tour a little closer, maybe 6-8 months.
So, who did you do ask to join?
Yeah.
We don't have any cool rocks, but
That's generally a qualification.
When you boarded like,
We'll make an exception.
Usually when I get here, it asks me to connect to your network.
and I'll send you the questions.
Somewhere I couldn't.
Because I'm sharing those with you.
Didn't either, but I would
And having similar
Yeah.
have been 4 strikes against me. At home if I had. That's enough. This is graduation. No, that was it. Yeah. You were definitely in the right place.
Yeah.
Oh, we do.
I'm
Yeah.
connecting to my company's website, so it must be on your Wi-Fi.
Yeah, something to think about.
It says it's asking.
In a good way.
there's
Look for the link or down the church.
Challenge is like for the
Be in his office.
Yeah.
for most of the US.
Sure, but it's always great to see you.
Yeah.
Thank you.
It's just, it's kind of.
How was your outing?
It was so good.
Sorry.
It's okay.
Wrong side. It was so good.
I'll look them up. Means I work.
How are you? Fill up the
So it's
table.
the father of the virgin.
No. Oh, man, it says the biggest boss in the room.
not seeing them because they didn't.
How are you?
Good. Layla got in.
I go to so. I'm good. Is this some kind of trick to make me have to crawl on the floor? See how long my battery lasts.
Risk it.
Yeah, we'll risk it.
Living on the edge.
Other people joining, so
Are you waiting to be Well, let's get started. We're having a little difficulty getting
say they're waiting for
tied into the meeting online. But I think we have a lot of people here and I think we've got a number of things that we want to cover. The goal of the meeting today is what we want to really be able to address is one, Christine has developed new updates on Christine sent out to the committee a draft document with protocol for how we can calculate top on them. We want to talk through any comments that the committee might have on that and hopefully move to be able to approve that. And then thirdly is I've got kind of a draft framework for salinity management going forward. I don't think there's anything too new there. It's mostly just kind of tying together all the different things that we've been talking about for a while. So, but wanted to kind of pull it together for you and talk through that today with you. And so hopefully we can move that into a document that this committee can review and then approve as well. So
Would like to have that approved before we finish our management plan because it would be a component of how we manage salinity in the berms in the future that we'd like to reference.
And the completion of the management plan is projected to be when?
So we'll have a draft published by fall.
in October.
Jeff is our consultant, so you can speak to him, but then finalizing it in the spring. late winter.
But I actually went into that meeting.
So, it's like, man,
Oh, Sid?
Christine's not. She needs to get in.
Yeah.
Can you
so it's
try to,
a way
like,
to do it.
Not join it and rejoin and see if it does anything different. A bunch of people just got let
So
out.
are you in the right meeting? Start with WGW.
Let me quick share my screen here. That'll.
WGW.
That's that one. Yeah.
How are you?
I'm gonna say, is this someone's seat?
All right, great. Well, let's go around the room and introductions, and then we can get going. Like we're getting things figured out here online. So, thank you, Jennifer. All right, so my name is Jeff DenBleyker. I'm with Jacobs, facilitating the Salinity Advisory Committee.
Oh, sorry, Christine Rumsey, USGS survey.
Mark Reynolds, US Magnesium.
Joe Havasu, Compass Minerals. Andrew Ruppy, Utah Geological Survey.
Linda Freitas, Friends of Great Salt Lake.
Joel Briscoe, I'm a recovering legislator and I'm her wingman.
Hannah Breeze, I'm Deputy Commissioner for Great Salt Lake.
Kyle Sound, Wildlife Resources.
Tim Harris, Division Ornithology. Ben Stireman, Forestry, Fire and State Lands.
David O'Leary, US Geological Survey.
Jennifer Biggs, Forestry, Fire and State Lands.
Jake Alexander, Forestry, Fire State Lands.
Angela Gong, Forestry, Fire and State Lands. Georgia Clarkery, Great Salt Lake Institute of Westminster. Jessica Stern, Utah Geological Survey.
Ryan Doherty, Cargill Salt.
Ryan Rowland, USGS.
Great. And then online, I see Ben Holcomb with DWQ, Leanna Littler-Wolf with DWQ, Layla Mahdi with Water Resources, Phil Brown with the Great Salt Lake Franklin Cooperative. Jennifer, could you scroll down there? Sure, we got everybody. I think that is everybody. Fantastic. So as you can see on the agenda, the first part, we're just going to go through some different updates that we typically do from USGS on lake conditions, from DWQ on their work, from Forestry, Fire and State Lands on their work. And then the three primary things that we want to make sure we cover today are just looking at our forecast for later this year, the draft method to calculate dissolved salt mass and salinity, and then a draft framework for salinity management. So hopefully we can make some good progress there and keep our momentum going. I think the first thing that we have on our agenda is just the meeting summary from our last meeting, which was on March 20th. We sent out the meeting summary for that to the committee members and wanted to see if there's any comments or changes that people would like to make. And if not, it's certainly entertain a motion to approve. Anybody like to make the motion?
I'll make that motion. Thanks.
Thanks. And the second?
Yeah, I'm as a non-voting member, I really want to do this.
All right. Great, thanks, Kyle. So I guess all in favor of approving the meeting summary, say aye.
Aye.
Any opposed, nay? Any other discussion? All right, they are approved. Thank you. So the first thing that we have on our agenda, the next thing on our agenda is just an update on lake conditions. And Christine graciously accepted the invite to do that again.
Well, I recruited Ryan, so he'll start us
All right.
off with all the water updates on
Yeah,
the
everybody.
salinity.
All right. Talk about the usual, we'll see it there. Okay, go ahead. All right, lake surface elevations. So there's data from October 2022 to current shown on the plot. Red line is the Saltair gauge, so the south half of the lake. Green line is the saline lake, so the northern half of the lake. The average daily value as of June 24th for the south arm came in at 4192.8. That's down about 0.8 of a foot since the seasonal high measured at this site in April of this year. The average daily value for the north arm for June 24th came in at 4192.1. That's also down 0.8 of a foot since the seasonal high measured there in May of this year. So in a typical year, we can expect an overall lake level decrease through this form season of about 2 to 2.4 feet. So we'll see how that plays out as we get into fall and winter when the lake levels begin to level off. Next slide. All right, major surface water inflows. We're looking at cumulative stream flow in millions of acre feet on the y-axis. It's a log scale. And then we're showing a water year on the x-axis. The bold black line is the current water year. And then the blue, orange, and green shaded areas are based on the historic record. The green shaded area represents the 25th to 75th percentile. That light gray line in the middle is the 50th percentile based on the historic record. So this first plot is for the Bear River Corinne. So currently you can see we're almost at the 25th percentile. We're almost at the bottom of that green shaded zone. And we've leveled off there. So it'll probably play out just about like that for the remainder of the water year, but we'll see. Next. Now the Weaver River, Plain City, exact same formatted plot. Bold black line right now is that same thing, about at the 25th percentile, maybe a little bit above. So we'll see how this plays out. Next. Gog and Drain, doing better at Gog and Drain in terms of the historic record. Bold black line is above the median, above that gray line. And so we'll see how this one plays out. This is good news. Next. And then the Farmington Bay outflow, where the bold black line right now is about at the median, about at that gray line. So those are the updates for our major surface water inflows. We all know the Bear River is the largest surface water inflow source, usually followed by the Weaver River. And so just to put that on a little bit of perspective, to see the Bear River inflows low is a significant thing. Next. All right, we make discharge measurements at the new breach. Currently we're doing monthly measurements during calm conditions. I know you can't really see this plot very well, but on the y-axis is south to north discharge in cubic feet per second. The range is about 800 CFS at the bottom to 1300 CFS at the top of the y-axis. And I'm showing data from October 2024 out to current. And so you can see how the dots increased during the runoff season. And now the most recent discharge measurement on June 9th, the values have dropped. And so the most recent discharge measurements for the last several months are there at the bottom of the plot. So last one was about 1,000 CFS. Back in May, we were about 1,300 CFS. April, we were 1,200 CFS, and March, 1,200 CFS. So that's kind of the flow trend south to north at the new breach. And there are indications of minor flow from north to south. Water maybe making its way over that eroded portion of the berm, but it's hovering around 40 to 50 CFS, and there's a lot of uncertainty associated with those numbers. So that's the update on the flows at the new breach. We also run a gauge at the old breach, the lakeside gauge over on the west end of the causeway. This is a daily discharge in cubic feet per second on the y-axis, showing data from October 2024 to current. You see the zero line, so anything that's below the zero line is flow moving from north to south through that breach, and anything above the zero line is flow moving from south to north. In the wintertime, in early spring, we saw some flow moving from the north to the south through that breach. Significant flows, getting up, pushing to 200 CFS. After that period settled down, then we saw flows moving from the south half of the lake to the north half of the lake, not reaching 50 CFS, so between 0 and 50 CFS, and currently hovering close to zero. Most recent discharge measurement with May 1st, 28 CFS moving from south to north. March 19th, 105 CFS running from north to south, and January 17th, about 5 CFS running north to south.
And the north to south flow in March, you think that's coming from the desert?
Yeah, I think we all kind of agree that that's what's going on. Next, okay, the lake elevation gauge. that is on the north side of the causeway near the new breach. Station 100, 127. I mentioned this last time. We've lost that station. The piling that it was attached to collapsed back in August of 2024. There's a nearby wooden piling, a couple of them actually, that we were thinking about attaching the sensors to, but we're like, I don't know, these things are pretty old, maybe not the safest to work from. But we're reconsidering attempting one of these old pilings because we don't have a viable solution to get us back out there right away. There's just not an easy way to get a new piling installed. So we're gonna take another look at one of these old pilings, existing pilings. But let's all just keep in mind, if we get an opportunity, if there's a modification made at the berm or any kind of major work along the causeway where we can have some heavy equipment, sort of build us a little path out to the lake, deeper in the lake, and then install a piling. And then they can kind of remove that little driveway they make for their tractor. Let's just keep that in mind. We have got to figure out a way to get a new piling out there.
Ryan, how
Yeah.
close could that be to the breach? Does it need to be located a certain distance away from the flowing water, or
Yeah, we want to be a little bit of ways. I mean, I don't know the exact. I don't know if we want to be right there, but we could be within.
just throw this out there? I know that there's not time for
75,
questions, but we were talking about having protective structures on either side of the breach, and if they were building those protective structures, that might be a good opportunity to place it on the,
Yeah, we can place it on
upstream
the
side of
away,
that.
yeah, on the side away from the flow.
and we'd have equipment out there, so we can try to work that into the discussions.
Let's do that. There you go. Awesome. Yep. All right, next slide. All right, hey, we're really proud of this. You may recall David O'Leary and others giving a press conference back in November around Thanksgiving time about a bunch of new strain gauges going in the Great Salt Lake Basin, most of the funding coming from Bureau of Rec. 13 stream gauges total. They're all installed. They're all listed here now. Everything in black was installed by the time we met last. The 4 sites in green have been installed since we last met. But these are now up and running. And I want to give a shout out to Rio Tinto because they are actually funding the Lee Creek gauge, which is very generous of them to do that. So these gauges are all up and running. Data is on the National Water Dashboard. Ratings are in development for some of these newer sites in green. So you may not see discharge yet, but stay tuned. We're working on the ratings. Okay. Next slide. All right, and some more exciting news. With that same funding that we got from the Bureau of Reclamation, we've installed 2 new buoys, water temperature profile buoys, out in the south arm of Great Salt Lake. One's at 3510 and one is at 2565. So our long-term monitoring sites. So they're measuring water temperature throughout the water column every 15 minutes, and we're actually transmitting the data to the internet so you can get to it every 15 minutes. So water temperature is reported at the surface through 27 feet at 1 foot intervals. And we've also installed some MET sensors on these buoys, and we'll see how those hold up. But the main objective here is the water temperature profile. And this is to help with evaporation work being done by Jake Sarago and others. This is going to help them get it at an energy balance, or at least understand the energy components of the heat stored in the lake. Next slide. Just a couple cool color maps showing this water temperature profile data collected at each site. So this is depth on the y-axis, and then we have time on the x-axis. The colored areas represent temperatures. Cooler temperatures are running from about 17 degrees. The cooler colors, and then the warm colors represent temperatures pushing 28 degrees. And so that's data from May to current. We're having some issues with the 2565 buoy. A big storm in June 5th, actually broke off the mast where the antenna and net sensors were mounted. We've got plans to fix that here soon. But this is tremendous data. It's going to help evaporation, and you can see how as we get into this group and others getting more detailed modeling of the southern half of the lake, this is going to help understand mixing, etc. So That's it for me, I think.
We'll just go through salinity update real quick. This is a plot showing the most recent salinity at two of the GSLEP sites, 2565 in Carrington Bay and 3510 in Gilbert Bay. Our most recent values were from June 10th when GSLEP went out, and they range from about 113 to, or 112 to 113 grams per liter is where we're sitting right now. Other recent salinities that have been measured were at the breach on June 9th, 112 gram per liter. That's really in agreement with our open water sample, and as well as at Saltaires on June 16th, also measuring 112 gram per liter. So that's where we're sitting right now. And in the context of our historic record, we are looking like we had, this is similar to salinities we had in 2017 through 2019. And May was our lowest salinity, so we are seeing the salinities pick back up now. If we zoom in a little bit more, here's a plot of all four of our GSLEP monitoring sites, so including the site north of Fremont Island where the Bear River comes in, as well as north of Antelope Island where Farmington Bay outflow comes in. Got them all plotted here from October 2022 when we had our high salinity to now. We can see that long-term downward trajectory again starting to come up again a bit. And relative to our last fall values, we've gone down 11 gram per liter since November and 12 gram per liter for Gilbert and Carrington Bay respectively. So that's kind of the magnitude of dilution we saw this season, was around 12 to 13 grams per liter. And now we're starting to see it concentrating as lake levels come back down. So if we look at this in the context of our isomass plot, again, this plot shows south arm elevation on the y-axis and salinity, shallow salinities on the x-axis in grams per liter. Again, for the data from 2010 to present, I kind of have an arrow denoting where we're sitting right now in June. And I just wanted to point out that we're kind of on this low end of masses that we've observed, of salt mass that we've observed during this last 15 years or so of data or of record. So relatively low salt masses, and we are within this kind of target range we identified for the spring of roughly 90 to 130 grams per liter. And just looking at estimates of salt mass change, here I'm plotting south arm salt mass on the y-axis from about June of 2023 to present. We're seeing pretty consistent declines, although the rate of decrease seems to be decreasing in most recent months. We're sort of seeing a stabilization of that. Most recent estimate of mass is 873 million tons. And roughly over this time period I have plotted, this is a decline of around 219 million tons of salt being lost on the south arm. So, and yeah, again, we're starting to kind of see it stabilizing. The rate of decline is less now. So with that, I think we'll go to the next, I'll save the salt forecast for later, it looks like, right, Jeff?
Yep.
Yeah.
All right, thank you very much. I guess next, Jim, you want to give some update on the rulemaking?
Yeah, so rulemaking is an update on the overall rule. Our board approved the permit limits, limited permit limits for mineral extraction operations on the lake at the last board meeting in May. So those are on the books, official. Thanks to everyone in the work groups that participated. That was a very helpful process for us. So we have one other item that we wanted to settle with regard to that rule, and that's to finalize the accompanying guidance document that I sent out yesterday. And we don't have a formal process for this, but so, if you haven't had a chance to look at it, we certainly can take comments if anybody has in intervening weeks. But in a nutshell, though, a couple of things that are remaining are, we'll discuss the methods for reporting current salinity later. And the other item is the determination of what is de minimis, what a de minimis discharge is for the permits. So the way we've organized this document, there are two items underneath a section that we call waivers, even though that wasn't the terminology that was used in the rule, but they fit under that definition. One being that the exemptions that are granted to those facilities that derive their waters from Gilbert Bay and discharge back to Gilbert Bay, and thus represent a net decrease of salinity or exempt from permit salinity limits. And the other is those discharges that are deemed de minimis. And so both of those are will require during the permit application process a petition to the state documenting their discharges and the concentration and the load of their discharges for us to determine whether or not that has a significant impact. It's going to be relative to the conditions that we observe in the lake, but with respect to the de minimis aspect, a de minimis discharge consideration will have to look at anything above when we have the permit limitations in place. So when conditions are above 150, we'd have to look at that as in terms of what we would review as de minimis. When the lake is below 150, obviously, we're not going to be placing discharge limits on facilities. So we'd have to consider the higher ranges. So it will be on a case-by-case basis and based on both looking at the concentration and the load reported to us from the facilities that are requesting that de minimis determination. And then we also have the flexibility of instituting a load cap for those de minimis discharges going forwards, make sure that nothing changes, right, in the 5-year period. The permits are extended for a 5-year period. We want to make sure that that things don't change or go above a certain load cap.
Is that with regard to like when the salinity is below 150? You're talking like an overall load cap or just?
No, just for the de minimis discharge, and it wouldn't be below because it wouldn't be a consideration for below.
But the load cap would be applicable when it's above.
When it's above. Are there any questions on that? I think we have some time if needed. We can reconvene the subboard group if there's a need to discuss this as I get comments back to folks. We have a little bit of time. In terms of we're not under such a tight schedule, but we would like to tie a bow on this guidance.
Anybody have a chance to look at it yet?
Yeah, I'll take a look at it. I mean, kind of the devil's in the details, I guess, in terms of what that load cap looks like relative to what what industry or Compass Minerals would consider negligible relative to kind of our annual salt load coming from the plant relative to the South Arm salt mass.
And one other thing I should mention too, this doesn't operate in a vacuum, right? We have all the permits that we process and put into place go through a public comment period. So there's opportunities for the public to comment not only on details of the permit, but also the de minimis discharge determination.
Great. Any other comments or questions on that?
I do. The mention of the rule requires monitoring of both salinity and discharge volume for all applicable discharges. So the recipient of the terms, the permit, the waiver would be the one reporting the numbers.
Yes. Yeah. Our UPDS, our discharge elimination system program, requires self-monitoring and reporting.
Great. Well, thank you, Jim.
Like Jeff, just a few updates. Really excited about the draft salinity plan and being able to have something, or management plan, and having something that we can use in our CMP to guide how we manage the berm and other aspects of salinity into the future. So we're really looking forward to getting that finalized. Also, just maybe an update on those voluntary agreements. June 15th was an important date for how water gets used in Great Salt Lake based on those. and the elevation that I reported at exactly 4193, which was 0.01 feet above the next threshold for when additional reduction would occur. So I was watching it all weekend over the long weekend, looking to see where it would land. Yeah, because I knew that we were going to get some calls from the mineral companies that were involved in that. So anyway, at this level, it means that there will be 50% reduction in use for the companies that have voluntary agreements in their operational water rights for next calendar. So the way it works is this June 15th is when we measure, and then the following year, that gives us some time to prepare operationally for how they would react to that. So anyway, I'll let Mark confirm or deny it, but I think we're pretty close to a voluntary agreement with use magnesium as well. So we're excited to be able to have that finished before water rights has their rolls out their distribution plan, so we can see what that might look like. But I know that they're going to be rolling that out here at the end of July. So we're really trying hard to get this finished with USMAC here this week or next, and we're thinking we can do that. Is that my right, Mark?
Just lawyers are our only obstacle.
Okay, well, Mark and I are on the same page here, so we think we can do it. But otherwise, I think that's all we have.
Ben,
Yeah.
what would the reduction have been if it were just below that?
It would have been a 70% reduction, so the next stage would be down to 30% of their full use.
All right. Great. Any questions? Comments on that? All right. Thanks, Ben. Christine, do you want to take? Yes, thanks to Lynn for bringing drinks. It was sugared up.
Working on it. Okay, moving on to salinity forecasts for the fall. Okay, we all know this is a simple calculation, many assumptions. But what I'm doing is I'm taking our June 10th measurement and I'm estimating what are we going to lose to the north arm, what are we going to gain from the inflows, what are we going to gain from the north arm to get a fall prediction of salinity. So the starting condition for this was our June concentration of 112 gram per liter and about 6.32 million acre feet. And then just briefly the assumptions that go into this are the variables that I'm modifying. I'm estimating a south to north discharge that ranges anywhere from 420 to 1200 CFS. So starting at our measurement now, which is around 1,000 CFS, and gradually ratcheting that down. And this is quite honestly just guesses based on what we've observed in the past. The berm condition is different than it's been in the past, so these estimates are kind of tenuous. And but it's just kind of we know some certain things will happen, and I'm trying to capture a range of possibilities. The climatic conditions, I consider 3 scenarios, so kind of an average condition for precipitation, evaporation, and inflow volume. I also consider a warm, dry scenario where evaporation is at the 90th percentile that we've observed. Precipitation is at 10 or 20%, and then inflows are also at 20%. And then a wet and cool scenario where precipitation is at 90% of our historical measured distribution. Evaporation is around 20%, and then inflows are also higher. I estimate what the salinity will be kind of throughout the season to estimate a salt mass export through the breach. And then inflows, I fix at 4 grams per liter. And another component that is really, I kind of think uncertain, and I want everyone to be aware of, is the amount of mass we're going to see coming back from north to south. We're already seeing flow coming in through the breach. As Brian pointed out, it was 50 CFS, kind of our last measurement. And as the two sides of the lake equalize, I expect we'll start to see greater flow discharge from north to south. And we'll continue to monitor those discharges, but it's really difficult to predict. It's really difficult to even estimate because, based on previous analyses we've done, there's a lot of flux that happens during dynamic conditions. We only measure during calm conditions. We get a storm, a really strong north wind that can cause complete, unidirectional flow from north to south. That's transporting a ton of mass. So I just want you to be aware that I'm not capturing all of those dynamics that don't exist in the system. So I'll just cut to the chase here. So here are the salinities listed, and I Each of these rows goes from our warm, dry scenario down to wet, cool. The middle one is the average predicted salinity, which is 118 grams per liter. That's only 6 grams per liter higher than what we see right now, which my gut tells me it's not correct. But based on the kind of the water balance variables we have and the equations I've used, that this is what this is generating. I would expect we're going to be more in the warm, dry scenario of less precipitation. We know temperatures are getting warmer, and that puts us at around 126 grams per liter. And then I also just threw in another scenario here of just comparing the two average precipitation conditions. But I'm on the second row of this, I'm saying, what if I get 4 times the amount of salt mass transported from the north, just to get an idea of what that will do to salinities. And it increases salinity by 4 grams per liter. So the amount of mass exchange that we will see at the breach does have an impact on the salinity value. Again, maybe just by a few percentage points, but it does change it, just so you're all aware. And then kind of based on an idea that Jeff had, I try to really simplified approach. And I think this is really kind of fun. And so I'll walk us through it. So on the plot on the left, what I did is I said, for every year since 1960, what is the lake level decline from our peak in the spring to our low elevation in the fall? And I just said, what's that magnitude of change in feet? First really fun observation is that that is increasing over time, which is, so it basically means we're seeing greater decline every year as time passes, which you might expect. We're just seeing more and more lake level decline during the evaporation season. It could be due to higher temperatures. This could be due to greater water withdrawals during the summer. I was also starting to play with, could it be just a longer evaporative season where we're starting to evaporate earlier, evaporation season is extending longer. But those are variables we could all, and analyses we could all play with moving forward to try to understand this better. But I basically used this to say, in 2024, the average decline based on this linear regression I fit was about 2.6 feet of decline. And I said, if I just remove that amount of water during this season, what would be the salinity? Just a very simple kind of, mass balance where I'm not playing with any of the variables I mentioned before. I'm just removing water from the salt mass we have now. And that puts us at about 129 grams per liter in the fall. I also just included the kind of a 95th percentile kind of range, so 127 to 132. So that gives you kind of another take on what salinity could be this fall. And then I kind of did the same exercise with just salinity change. So in the fall, or sorry, in the spring, what's our seasonal low? And in the fall, what is our seasonal high of salinity? It's just that magnitude of change from 2010 to present. And sorry, these are kind of hard to explain. And I did divide it for each. I calculated it separately for each site. Curiously, we see a huge amount of change happening at our 2267 site, which is the Bear River site. So that might give us some insight into lake dynamics, just something to think about moving forward. But if we consider kind of our more south arm oriented sites, we tend to see increases in salinity from spring to fall on the order of maybe 15 to 20 grams per liter, just to give us a gut check on those forecasts that I presented. So, and then if I go back to our isomass plot, I kind of take into account the lake elevation changes we expect and the salt mass changes we expect. This is kind of the range in which we might see our fall salinity in 2025. So just shifting where we are now to higher concentrations and lower lake elevation. And really the salt mass, I don't have a good sense because I don't know what's going to happen at the breach. I don't know how salt exchange is going to happen there this season. It's just a kind of a condition we've never seen before. So kind of an unknown. And you want me to just keep going?
Well, any questions?
Any questions on the forecast? So you're working on something.
For the north to south, were you assuming constant flow of 50 CFS through the?
I ratcheted that up too. So I
Okay.
went from like a 50 CFS to maybe like 100, 150 each month. I like slowly ramped it up.
Okay,
And then when I did the 4 times, I basically just multiplied that.
okay, very.
Thank you for,
I think based on that, it's going to be really important to watch the salinity and the flows from the north to south to see if there is a point where we need to consider blocking the north to south flows. But I think, my gut is that like we're going to end up in a pretty good place in the fall to be within the parameters of what we want to be. But I do think the one thing we need to consider is that we're probably, I think most people agree we're heading into another period of drought. So we probably want to be pretty careful and, conservative on how much salt we let the back end and how much we hold on the south arm.
Yep, that makes sense.
So I think it looks like if we left it the way it was, based on what you're projecting, we'd be in good shape.
Yeah, yeah.
Which is nice to know.
And I forget when exactly they did it, but our crews did a drone flight of the berm. And based on just their visual observations, they say it's changed quite a bit. And I know they're working on processing the data and hopefully can get that changed soon, but it sounds like the notch has steepened. And so that also might inform, our understanding of how much flow we expect from north to south.
Do you happen to have any sort of sense of when they might have that process?
The last time I talked to them, it was a few weeks out. So let me check again.
That'd be awesome. We actually, with the berm analysis that Jacobs did, we feel like we need to go report back to the legislature since they asked us to do that. And so we'd like to kind of give them some details about, I guess, how we think we should proceed and what's in there. And I think a strong component of that is that if we don't have money to do like the sophisticated structure, at the very minimum, we can try to protect that so we don't have waves and other things unintentionally alter the berm. So it'd be great to be able to exemplify kind of how sessions and other wave action has modified that also with our consent.
Yeah. Okay. Yeah. I'll let folks know. I can try to get that out quick.
Awesome. Thanks, Christine.
Great. Yeah. No, thank you.
You're welcome.
The kind of our holy grail is to be able to predict, more than 6 months. I think what Christine's done to give us a forecast of 6 months is already a huge step forward, because it now allows us to consider, can we make some changes to the berm here in the short term. Being able to look out 12 to 24 months, provides forestry state lands even more heads up on what they might need to do in terms of, trying to get more money if they need to, or do, formal engineering designs, et cetera. So that's where we're trying to just play with some different ideas to how might we be able to forecast further out than 6 months. So anybody has ideas on that, please let us know. But yeah, knowing what the inflows to the lake, are going to be is, that's a big question everybody has. So.
Yeah. And I forgot to mention this, but I wanted to say, this is really striking to me because like last summer when I tried to predict, I would think in about this time predicting fall, I was off. I was like, it's a 5 gram per liter increase. And my gut is telling me it's gotta be more. It's gotta be in the 10, 15, 20 gram per liter range. And this is telling me a little bit that we're dealing with non-stationary. So when I use historic climate data, it's not going to be representative always of our current or even future condition, because we're seeing increases in temperature, we're seeing changes in the way water is coming down, all these things that are actually not captured in any historic record. So I just want to make that make that point that predicting these things is also made more difficult by the fact that we're kind of entering a realm where the historic condition is not telling us about what the future is going to do. And this slope is just, telling us we're ratcheting in a certain direction toward more evaporation, toward potentially greater temperatures or whatever is driving that. And so just keep that in mind as we try to guess the future.
It looks like the spread is tightening too. Maybe I'd be curious what like an average 5-year R squared. Yeah.
It also seems like before the 80s, the trajectory would have been more flat, and then it started to rise. And I wonder if like when the lake is low and we have, it's harder for the Bear River Bay and Farmington Bay flows to reach the main body of the lake, and the soils, taking up a lot of those summer flows. If that could play into it, or even just the expansive exposed playa that soaks up a lot of that water that would have otherwise kind of stabilized the elevations. Like those feedback loops that just by having a dry lake bed, it's not so much the climate.
Yeah, exactly. Just like the efficiency of water getting to the south arm. Exactly. Yeah.
At the latest last trust meeting, Darren Hess attends those. He's on the trust, and I think there's a component we're not talking about here, and that's the upland soil moisture. I mean, we spend 15, 20 minutes talking about, you know, it was lowish going into this, you know, into this snow year. They recovered, they thought they recovered, but actually they showed to be low. And what you know, Darren surprised. You know, they were expecting an 85% inflow in Weber Basin, which is a significant contributor. They were expecting 85%, is actually 55%. Because my question to him was, what happened? Like, you know, it just kind of plateaued in April. You know, if you had good soil moistures, like everyone was assuming, you know, February, March, you know, that would have gone into June 15th. You know, it could have extended.
Yeah, there's a lot of factors. You know, I mean, even where the snow level line is, I think at our high elevations, we got lots of snow. But at the mid to low, and here in the valley, I don't think I had to shovel my driveway once in winter. So I think there's changes in where that elevation is and how fast or how efficient is that snow melt.
He talks about more about dry fall season, you know, and just really kind of going into the season kind of at a deficit. Need above average to recover from that. But in terms of this predicting further out, I don't know if we could invite like a water manager. I know it's not associated with the lake, but that could, you know, it sets up.
I don't think we've done a lot of like guest presentations in this body, but I think it'd be cool to have incorporate some of those things, or even the folks who are working on the ET modeling and all that fun stuff.
Yeah, and he brings, you know, information on like the reservoirs are relatively full. Okay, so that's good. You know, after maybe a disappointing inflow.
Oh, great suggestion. Yeah, that's all. I think for us to be able to manage, I think we're developing the tools to be able to assess the lake and the direction that it's heading. But the more advanced that, you know, the better the decision we can make and have more time to be able to make changes that we need to better. And otherwise, we're having to be reactive and building things. It's hard to do that and reactive.
But I think with that information, you know, if it was a dry fall through November, you know, I think that could inform you, Dennis.
Oh, yeah. I mean, I think if we did this, I think with this plan, we'll be able to hone in on like when we need to meet to be able to make those decisions and have enough time in the predictive models to know like where we're at on snowpack and the water year and all those things. So I think that with the completion of this plan, we'll be able to meet less frequently, which is I think what we intended, is like four times a year rather than, you know, really often as we're leading up to the peak salinity and low lake elevations.
Great. Thank you, Christine.
You're up next. Okay, cool. So I sent out, I think a couple weeks ago, this draft document, which goes through a methodology to estimate South Arm dissolved salt mass and volume weighted salinity values. So Jeff asked me to just kind of go through the key components of this document, and then we can discuss if you've read it, if you have any feedback, any changes. And I think this, it's just important to keep in mind that I sort of distilled this from conversations we've had and from needs that I understood, and it's possible that I didn't hit the mark. So please just, in the end, just say like, we actually need something different. That's fine too, but that's the point of this iteration. So the purpose of this document, there's three kind of key things. The first is to document the approach to calculating a South Arm dissolved salt mass. This is kind of what I've been doing and what we've been using to track how salt mass has been changing in the South Arm. The second objective is to develop methodology for a South Arm upper brine layer volume weighted salinity estimate, and that dovetails with Jim's kind of implementation guidance, as well as the rule for the 317. And then the third thing that we wove in here that may or may not fit, but we wanted to kind of just share this ISO mass plot idea and just share how this framework for how we're integrating salinity, lake elevation, and salt mass as a way to track current conditions and predict anticipated conditions. So first, I'll just start out with kind of giving an overview of the data that are going into this. all these methodologies they're dependent on Great Salt Lake Ecosystem Program for collecting water samples each month at their 4-site monitoring network. And that's shown in the map here. And these are the sites I always present salinity data from. At our deep sites, let's see if I can get a pointer going here. At our deep sites, 2565 in Carrington Bay and 3510 in Gilbert Bay, we collect 3 samples in the water column, 0.5 meter below surface, 3 meters below the water surface, and then 0.5 meter above the bottom. At our shallow site 2267, this is where the bear comes in, we collect samples from 0.5 meters below surface and then 0.5 meter above bottom, which is I guess 2 to 3 meters typically. And then at 2767, recently we've only been collecting 1 sample at the shallow depth, 0.5 meter below surface, and that's because this is a relatively shallow site. So we have all these, we get 9 water samples per month from these 4 sites. We measure the water density in-house at 20 degrees C, and we use that to estimate salinity with the Great Salt Lake equation of state, which was developed by Dave Nass, and that has been documented in its own methodology and published by USGS. So that's where the data are coming from on a monthly time step. So then to calculate the South Arm dissolved salt mass, what we're doing is we're kind of dividing the water column into 3 layers. So from essentially 0 to 1, from the surface to 1 meter below the surface. And our second layer is typically from 1 meter to about 5 meters below, but that's based on a water quality profile. So GSLIP also collects measurements throughout the water column every meter. And we use that to identify if there's a chemocline using the specific conductance. And then that is used to define this depth here. And then the bottom layer is from that chemocline depth down to the bottom. And so these kind of delineations, these slices allow us to estimate a volume, a water volume, to pair with the concentration that is measured in that layer. So the mass then is generated by multiplying the concentration times the volume of that layer, and then adding these different layers and masses together, if that makes sense. And we do this for each bay. So here's an example of how we'd calculate the mass in Carrington Bay, which is that northern bay just south of the causeway. And then to get a mass of the South Arm, we add Carrington Bay mass to Gilbert Bay mass. So this is how we are getting the salt masses that you see, that I present to this group. And so that method is documented in the fractionally for them. Yeah, and then I just noted that these masses are used to track the South Arm salt mass, evaluate current conditions, and inform the management, as you all know.
Can I ask a quick question?
Yep.
Christine?
Mhm.
So the water quality profile or for the layer 3, that depth is determined by connectivity, and that's also taken every month with these samples.
Yep.
Okay.
Yep, that's the other purpose. And we did ask GSLIP when we start, if and when we start to see the deep brine layer come back, for them to identify specifically where that is to the best of their ability. Because when we have to snap to a 1 meter measurement, like that's quite a bit of error. Like a 3-foot distance, like that can be a lot of volume error, a lot of error in the volume estimate. So we've asked to just get the best estimate of what that actually is each month. That makes sense.
Have you been seeing a chemocline and the
Yeah.
lately? So in lieu of a chemocline, do you take a water quality sample 0.5 meter off the bottom?
We do. Yep. Yep. Mhm. We always do.
Always.
Yeah.
And so if you don't see a chemocline, that gets lumped into,
If I don't see a chemocline, I tend to just use the 5. And then it's just sort of, there are really gradual gradients typically. It can be fresh and then a really gradual, maybe 0.5% to 1% increase as you go down. And so, yeah, I still use that 3rd layer. It's just less meaningful without a deep brine layer. All right, so then going into the kind of the second main objective, which was to quantify an upper brine layer volume weighted salinity estimate. So this was something we agreed on at the last Salinity Advisory Committee, that this would be the kind of the most representative salinity value for the rulemaking process. And so what this does is it essentially just takes it defines 2 layers that we're calling the shallow layers. The first is still from the surface to 1 meter below the surface. And the second is from 1 meter below the surface to 4 meters below the surface. And 4 meters was selected because it's pretty much, it's very dependable that we'll never get deep brine layer in this kind of the 4-meter delineation. So and that, which is what we wanted to exclude specifically, was we wanted to be kind of in this photic zone where the biological activity is happening, or I guess I should say the macroinvertebrate productivity is happening. And so this follows kind of the same ideas. We're pairing the concentration with the volume, adding them up. This is just a conversion factor, and then getting the mass of this upper brine layer, we're calling it, in the Carrington Bay. Sorry, I don't know, the formatting of this got all wonky. Let me see if I can fix that. Yep, and then we just add up the masses from Carrington Bay and Gilbert Bay for this kind of top 4 meters of the water column. And then to get a volume weighted concentration, we just take that mass and then we divide by the cumulative volume in both of those bays. So that's how that concentration is generated. And then I'm saying values account for dynamic upper brine layer dissolved salt mass in the photic zone, capturing conditions relevant to self-arm benthic and pelagic ecosystems, and aid in near-term management and regulation of salinity. So yeah, these shallow values are kind of what I think we've thought of as being, what is our condition now? Is it suitable for the ecosystem? And it's very kind of a near-term metric, whereas when we consider all the mass, that's kind of a more of a mid and long-term estimate, because we're just considering what could be mixed into this biologically active zone. And then lastly, what's in the document is this framework. We just kind of formally discuss this isomass plot that we've been showing, and just highlighting that it's really able to capture the evolving connections between dissolved salt mass, salinity, and lake surface elevation. So it's integrating 3 really important variables that we look at together. So in this, and using the shallow salinity measurements. So these are basically just data. There's no calculation happening here. It's just the density is converted to a salinity. And again, this is what I think, from what I understood, are considering to be a good metric for near-term management and kind of an assessment of like, where are we right now? Whereas the next one that I developed was using the volume-weighted salinity. So you can see the x-axis changed to a volume-weighted gram per liter, and that's essentially accounting for all of the mass in the water column. And it's kind of hard to tell, but basically those values, when there's a deep brine layer, they shift to the right. So salinities are a little bit higher when there's a deep brine layer because we're accounting for all of that mass. And so, yeah, I think that, so this again would be kind of more suitable for a medium to long-term planning of where we are and where we're headed. And those are just kind of side by side. And again, it's very hard to see that because it's very subtle, but for example, like all of these values, which are raw measured values, are kind of snapping to kind of a mass that is kind of, well, it's higher. And same thing with, I'm trying to see, oh yeah, like these purple values are kind of snapping more to a higher mass value. Again, because they're capturing the mass in the deep layer. So there are subtle differences, but there's 2 tools that I present and just hear that I've heard would be useful. Again, maybe they're not, but that's what's in the what's in the back. So happy to take feedback on this.
I have a question because I sent you some of my comments. I was just looking at some of the graphs you presented, I think at the last SAC, with regard to, we did kind of a subtraction of different sites from Salinity estimates to compare the differences.
Yep.
And I didn't see in there a scenario in which this 4 meter on the left, how does that compare? Do you have a sense of how that compares as a concentration to the volume weighted? Did they vary significantly?
I think it was like 1 to 2 grams per liter. I think it was like very minimal. Yeah.
So one of my concerns was having multiple methods for reporting, right? I mean, I certainly wouldn't want to use a number for lake management and one for just our permitting and et cetera. One for, you know, or it would be confusing, I think, to the general public at more than one number floating up there. And they both exclude the deep brine layer in terms of the shallow sites. So I guess, and if they don't vary considerably, I would make the suggestion that we select one of them preferentially over the other, depending on which is more meaningful. obviously when we're talking about the volume weighted salinities and you're including the deep brine layer, that's a different graph, a different view of the lake entirely. But if we're talking about reporting of like snapshot, this is our lake salinity currently. I would like to pick one number and come to an agreement. That's the viable number.
And it seems like we've kind of already agreed that we're excluding the deep brine layer in that snapshot salinity because it's about what's happening in the column for the ecosystem at that point in time. But then when we're talking about long-term management, like Christine has here, we're looking at the volume weighted salinity. And I think that's a good point. We don't want to have two salinities where someone's reporting this and someone's reporting this. So my recollection is that we kind of agreed that we were looking at the upper brine or excluding the deep brine layer.
Right. But it's a nuance between the method of taking the raw data that's less than 4 meters deep versus volume weighting the same data,
Well, and I think the volume weighted salinity, maybe one thing that we could do there is with the volume weighted salinity, we're just looking at the total volume and not a gram per liter volume. Because I think that the salinity management plan, a lot of what we're looking at is like, what's the total salt mass, right? In relation to the elevation. And we'll know that like at this elevation, we kind of have targets that we want to be at. So predicting the rise and fall of the lake versus what the salt mass is, we can kind of get an idea of whether you need to raise or lower the berm. I mean, is that more or less how that plan works? So I wonder if it's necessary to have a gram per liter measurement for the total column. I don't know if that's just a thought maybe to throw out. But
Yeah, we could just, you mean kind of just remove that from that section.
well, just as to not confuse folks.
Yeah.
Maybe looking at the total salt mass rather than the volume. 'Cause I think that's I think that's what we are looking for is we're trying to understand the total mass when we're talking about the whole column. That's what's important. It's about we manage long-term and it's about the mass, not the concentration
Yeah.
at that time. But I
yeah.
don't know, someone, Jeff, you should confirm. I think that's how I understand it. And I want to make sure
I think salinity management is going to be, that's what you're saying is it's going to be about managing the total volume weighted mass of the whole water column.
So to Jim's point, not having two concentrations that could potentially compete might make it more clear to the public. But I think like as like internally, I think we could still have, places where we obviously reference specific concentrations. But I don't know, that's maybe something for more discussion if others have strong feelings.
See, but the concentration is the number that drives everything, right? So it'd be nice to have that number as well.
But I guess the question is we have a concentration that's only representative of the upper brine layer, or do we have a concentration that represents the volume weighted?
Okay.
Well,
Yeah. Okay.
I guess what do you mean it drives? Andrew? I think when we're talking
The number that people understand it can take in.
Oh, yeah.
That affects all that.
So I think that what we're saying is we still have the concentration, but it would be representative of or excluding the deep brine layers. But then when we're talking about long-term management and looking at the whole column, it would just be salt mass. Just to keep people confused about, why we're reporting out on two different concentrations.
So in this document, the only concentration we mentioned would be the concentration of the upper brine. That's upper brine layer volume weighted.
Yeah.
Okay.
I think, I don't know, does anybody see issues with that? I kind of just spitballing here, so I want to make sure.
The only thing I can think of is like the modeling, the mass balance models that we have of the lake have traditionally used that volume weighted salinity value, which is what spurred the question is, well, that's a higher salinity than what we're seeing when we're measuring things in the field. So your point is spot on. It's confusing when there's two values. And I think in terms of what we report, I think what I'm hearing is that we would report the upper brine layer because that is the ecology, the natural resources are seen. It's largely, I think, what the industrial.
This is all towards protecting biota in the lake. So if that's where the biota reside, then
Maybe just one other thing too to think about, I guess, if we're going to modify this document, I don't think that the public's looking at this document and will get confused. I think what we report is like, the hydromapper or other places where we're talking about that. So maybe it doesn't matter if like in our own report, we keep it in concentrations. I don't know. I don't think that's, that among us, we would be confused.
I think having a protocol that spells out, here's how you would calculate it. I think that's the intent of the document, is here's how we're calculating these different things. Maybe we can make sure it's clear in there that only these are contemplated for use, you know, in terms of public reporting. But I think if, and I don't know if I saw Craig and Layla are on Laura with the lake modeling, the mass balance modeling that we're doing. I don't know if there's value in protocol for the volume weighted salinity or not.
Maybe another dumb question to add on to that for those that model these things, but like, wouldn't the concentration of the upper brine layer be what's important to them when they're thinking about evaporation and whatnot? Like, they're not going to need to take into account the deep brine layer. So
I think that's true, but I think when we think about predicting long-term salt or salinity, then we definitely want to make sure we get all of that in there.
and that'd be more about where we're like doing those berm modifications and all that.
Yeah.
Stuff.
Hey, Bill, you have your hand up?
Yeah, Christine just addressed what I was going to say. The deep brine layer remains separate under certain conditions, but it mixes under other conditions. And so it does have to be acknowledged somewhere that if it mixes, you're going to actually increase the salinity by that amount. And so it can't be ignored completely. It just has to be clearly stated that it's a prospective value if the deep brine layer mixes. That's what it represents.
And Bill, I think to your point too, that this is also maybe something that we need to hone in on or refine as well, as like, you know, if we have a deep brine layer and we get to the point where we're, you know, making decisions about like closing the berm again or something like that, that's when we would start to see that deep brine layer, you know, go away and mix back into the column. So we'd have to understand that impact on our decision to close the berm. So when the deep brine layer is there, how much, you know, salt mass that represents. And then also, I think it's really important as well, that somehow we start to get a grip on like predicting when the deep brine layer is present, how long it exists for, things like that. Like, you really need to start to, you know, document the formation of the deep brine layer and how long it resides and under what conditions, so we can use that to start to inform the, you know, the tools that we have available, like managing breach. But I don't think we're there yet. I don't know. Yeah.
Really depends on the breach exchange at the breach.
Sure.
And yeah, I wish we could figure out continuous monitoring there, because that would really, you know, getting a monthly time stuff is really tricky for understanding the dynamics of the deep brine layer. I mean, other than monitoring it itself.
Maybe long-term goals of.
Yeah.
So overall, Christian, I think I really like this. As I was reading yesterday, I was thinking about 2023, and we kind of had the non-traditional sort of stratification where it came up. I mean, there was stratification in the north part of the lake, it was at like 15 feet. In the south part of the lake, it was closer, somewhere between 15 and 20. I'm not sure where. And I was just thinking about whether this would work in those scenarios. And as I thought about it, I think it would. But I'm just throwing that out there to see if anybody would disagree with that. So if we have stratification that creeps up a little higher than sort of this traditional sort of deep brine layer.
Yeah, and you're thinking of more the condition where we don't really have a deep brine layer, but we have this like really like a lot of dilution in the surface, and you see this kind of like gradient from the top to the
And
bottom.
there's a fairly stark
Yeah.
contrast there between the upper and the lower.
Yeah, because I think there's going to be this delay in mixing where you kind of get the previous seasons being stagnant at the bottom and then this fresher lens coming in top. Yeah, I think it's a great point, Andrew, and something that I had considered in these different layers. Because like the top meter kind of really trying to bracket like a real fresh condition that might capture kind of what you're discussing. And then this layer 2, you might have a gradient that's like, you know, more dilute to gradually, they tend to be pretty linear from what I've seen. And so my idea in this layer 2 is that this measurement at 3 meters below is kind of the average of that a little bit. Because you're kind of in this, if you have a linear dilution or a concentration toward the bottom, then that middle, having a sample right in the middle of that is kind of capturing the average of, and slightly, is representative. And then if we do see a chemocline that's pretty drastic, we can adjust where that, like the chemocline that we assign between layer 2 and layer 3. So I think we could get there. And honestly, without more samples, we can't really capture it.
Assuming that that hemocline doesn't exist above 3 meters, right?
Yeah.
Which I don't think I've ever seen.
Yeah, right, yes,
But that, I mean, that was a pretty unusual year.
yes, it was. That's a
So
good
maybe
point,
it's
though.
a non-issue.
It's a good point. And yeah, and if we wanted to get at that, really nail that down, I think we need to consider adding more samples throughout the water column. And even, I don't know, continuous monitoring would be really great of salinity throughout the water column.
Kristen, I also think this is fantastic, and I think that this is the best we've ever had, right? Like, we're like light years where we were 5 or 7 years ago. And so, but I think this is not the last version that we'll do, right? Like,
Yeah,
we'll figure out that there can be some weird year,
Yeah.
and we'll have to figure out what to do in those years, and it might be like more sampling at different depths, or
Yep.
maybe we move towards continuous monitoring if this doesn't just quite nail. But I think we're like to the point where we're going to be pretty well refined, and then we have the tools available. Like, if we work with a little bit and we needed to export salt, I think we know how to do that pretty well now. So I think that this will be able to refine all of this information over time. So
Definitely.
I think it's awesome.
Yeah.
Great.
I think one more comment. I think keep in mind, so in addition to those discrete samples, the where the densities measured and the concentration, salinity concentrations measured, at the ecosystems, Great Salt Lake ecosystems is doing a water quality profile with their sonde, so we'll know.
So we'll
if there's
see
some
something,
weird
yeah.
phenomenon that we might have to, think about with the additional samples.
And Andrew, we probably could develop a pretty reliable relationship between specific conductance and salinity. There would be some uncertainty there, but we could use those kind of more resolute or higher density field measurements to convert it to a salinity if we wanted to play with that.
Yeah, and that's true. If you guys are doing that, we'll see something.
And that's why we talked about it in 2023 is because we saw that anomaly.
Yeah. Okay, super.
Yeah, I think I guess try to recap is, in USGS, GSLEP, I've been collecting these samples. There's usually, 8 to, anywhere from 1 sample at one location to 9 on a given day. And so we typically see a range of salinity across the lake. And so when we get to a need like with DWQ where we have a limit for the upper brine layer, where the hydromapper, we want to report a salinity with a salinity management plan, or when we look at a matrix, what value should we be using? The need was, well, could we come up with one kind of integrated average number that we can use that represents that upper brine layer that people can look at and understand what it is, rather than seeing a range of values. So that's what this method does, is gives us that value. And I think it also importantly provides a protocol that we can continue to use, others can use to compute that salt mass. And I think the salt mass, I think when Phil Brown first reported and said, hey, I'm seeing this anomaly in the salt mass, how it's changing back in 2021. And then we all like, whoa, that's what really kind of kicked off the whole berm discussion, is what can we do to try to manage this. And so I think this really tries to encapsulate a lot of that, the methods, the things that we've talked about, and to try to come up with a value for the upper brine layer, a salt mass for the south arm. I think if somebody needs a volume weighted, I think as was pointed out, if the south arm was to fully mix, if we had a deep brine layer, that volume weighted gives us that. It gives us a lot of options, gives us important data to be able to assess where the lake is, and also be able to make some decisions as to where we want to go. So I think I appreciate, Christine's done a ton of work and looking at all of the data, what if all these what ifs, if we pull the shallow depths, if we pull out some of the gauges or some of the sites, just looking at everything. And I think this, you know, and then we've had a number of you participate on a number of calls over the last 6 months as well to discuss this, and I think a lot of great input to shape this. So I think we'd love to be able to finalize this, and yeah. So if, I guess, does anybody feel like they haven't had a chance to review it and still want to review it? Or do you feel like it's something that's ready to approve that we can start to implement?
Jim, did we like kind of address your concern?
Not to get too weedy.
Yeah, no.
Just to clarify, and maybe I'm misunderstanding your document. The points, the measurements of salinity concentration in the left graph, those are not volume weighted. Correct.
They're just measurements.
So,
We could.
yeah, that's the question I have. If we select a method, either select this one that's presented here.
Yeah.
If it doesn't, if we agree as a group and it doesn't vary that considerably from a volume weighted method, or if we all feel that the volume weighted method is the more appropriate way to go, given modeling, given everybody's understanding of the lake, is it more accurate, even though maybe right now it doesn't vary very much. Would we also be proposing to modify that graph to just be a volume weighted,
We could.
shallow?
We definitely could.
Okay.
I think I put that in there because that's what we've been using in
Right,
a lot of these
historically.
meetings and to explain it, but we can certainly, I could amend it to basically put it under upper brine layer volume weighted section and just create like that, this figure, but only the top 4 meters volume weighted. And maybe that would be more consistent. And then is that kind of?
Yeah, that,
Okay.
that way we're not, again, it would just be no one would really understand the difference, but to
Yeah,
us,
yeah,
that
yeah,
you're
yeah.
using a different method
That
to
makes
present
sense.
that.
Okay, so in that case, let's see, should I remove that one from the document? Does it just add?
I don't know.
confusion?
I think I would like to know the group's position on which method we adopt.
Yeah, I think it's confusing because we tried to honestly just put this in here because we just wanted to document the isomers. This is not a method. It's really just a way of presenting the data and looking at current conditions. It's not a method. And so maybe that added confusion, and I'm happy to remove that if it just, but yeah,
But that is what gets reported to the public, right?
these salinities,
Yeah.
the raw salinities.
Yeah. No, the volume weighted for the top 4, the greater than 4 meter depth, the shallow.
Yes, but
salinities.
these are just kind of raw measurements. So these are just like the 7 measurements taken per month, all put on a plot. Whereas what we're talking about
Okay.
reporting
I'm
is
sorry,
a,
I got you.
Single.
is a single value that is a volume weighted calculation of those.
Yeah. So the right graph, just to make sure I'm understanding, is still just the excludes the deep brine layer.
Right, that one includes the deep brine.
But that's not what we have historically reported out to the public. That what we report on like the hydro mapper is just the upper brine.
They're
layer.
basically measurements. Yeah, they're raw measurements at 3510 and at Saltaire.
So I guess the question is like, what are we gonna use the document for? Who's looking at it? So we don't confuse people who look at it and say, hey, why does this one say this? But when I look at the hydro mapper, it says this, because the folks who, if it's the public, they're gonna be confused. If it's like I don't think anybody here is gonna compare this to the hydro mapper and wonder why it's different. So I just want to make sure that we don't confuse anybody.
Yeah.
That's those.
Exactly. So happy to make changes so we don't confuse anything.
Can we just relabel that graph to say this is the reason this exists? Like maybe put a little premise on it of like why that graph exists and how it's reported out. And that's what's represented in, salinity.
This
reports to
one on the
public.
left.
Yeah.
I mean, really, it's not reported to anybody but this group. And that's just so you can all can see where we are and assess the current conditions. This is not reported publicly to anyone. One on the left.
But you can access the data for each individual measurement plotted on there. If you know the station number, you can go to this database, and the public can, and get the value for each dot represented on that map.
So the one on the right though is also not what is being reported out on the left.
Yeah,
So neither of these.
None
can
is
be
reported. Nothing's being reported essentially right now, other than a raw measurement at 3510 on the hydromapper and also from Saltair.
I don't see the public using this document.
Well, my keen interest is that we just arrive at a method for reporting a value for the current condition.
For the implementation of your rule.
Yeah, well, and I mean, I think it serves a reporting, that's a simple number, right, that we give to the public as well, like that. Okay, the current salinity in the lake is 140.
But neither of these are that.
No, but I just wanted to understand the nuance of these to make sure that they were consistent with how we derive the salinity.
Yeah, we are kind of just combining many purposes into one document. And so there is one section that's like, here's how we will calculate an upper brine layer volume weighted salinity for this purpose. And then there's these other sections that are not really related to that, but have serve other purposes. And maybe it's confusing that they're all pulled together.
But it seems to me like maybe we should get just a small group of people that can brainstorm this and work on it, bring the final draft back next time to adopt it as the.
Just make sure it's clear.
Yeah, just to make sure we're all. in
I
consensus on
mean,
that.
kind of in each section of this, kind of lay out the intro paragraph. This is what this is for. This is, just be very, very specific. And
We
it's
could talk about,
already,
we should talk about this document, what is reported in the
Yeah, I think that'd be awesome. Like, here's how we report to the public, and the reason why it's slightly different is we're reporting on those things that the people, ecology, other things are going to be worried about, right?
And that was one of the other questions I had for our guidance too, is where do we point people, permittees, to track the current salinity? What's the hydromap would be the most appropriate site for the most up-to-date information? Or do we take information we get from you and put it on our webpage? We should
Yeah.
work that out.
I mean, we are updating the hydromapper now, and if it's decided like we want to report this upper brine layer volume weighted salinity, we can just make a graph of that and add text saying, here's how this is calculated for multiple measurements, and just so that it is consistent. Because I think when we develop the hydromapper, we're like 3510 is generally representative of the Saltair in a lot of cases. So is Saltair, and we get those at a pretty high frequency. We just wanted a simple value that people could have some idea. We could certainly revise that at this point, now that we have this method and just have one salinity value.
And I think depending on the magic that Christine can do,
Yeah.
the hope is that we can automate, pull from endless the measurements that are made at the different sites that are reported into the database. And so that we can, on a website, be able to run that algorithm so that we're reporting, here's the latest upper brine layer salinity value. And so that we can all, if you want to point, pull that value from hydromapper or, wherever that number ends up, then we can all be referencing the same.
Yeah, I think Jake Vanderland in our office had created a little dashboard that he basically did that, where he just tapped into NWIS and reported it back.
Does that screw up the historical data though on the hydromapper if you all of a sudden go to a volume weighted upper brine?
I could calculate a historical upper brine layer, like we would make the whole
You could
record.
just extrapolate it out.
Yeah.
I would tend to think that that would be.
But I will say the challenge is that we only started measuring the 3-meter depth salinity, I think in 2023. So the problem is just keep in mind, I can basically say the half-meter sample is representative of the top 4 meters, but there will be more error pre-2023.
Yeah, I think I did genuinely misunderstand this graph, because I thought this was also displaying that those as a average, but they're raw data, so
Raw data,
that does
yep.
not
Yep.
conflict in any way.
Okay.
Great. So I think, Ben, your suggestion's a good one is, we can meet one more time. Bill, sorry, you got your hand up.
Just a nitpicky thing on the previous slide, but I think it's worth addressing. In a legend on the left side, it calls these date ranges a paradigm, And a paradigm is usually an interpretive framework, right? And so I think that term might be a little bit lofty for, I get what you're trying to represent. You're trying to represent periods that also have some external forcings. So they're not just date ranges. But I'd suggest a simpler term like regime or period or something, because paradigm implies a whole theoretical framework around this that, that's not what this is. This is just a way of portraying data.
Okay.
And so, yeah.
Great, thank you. So I think the next steps will be to schedule another a subcommittee meeting. Well, if you want to participate, please let me know. I think we'll lean on the folks who we met with before, which frankly was most of the Salinity Advisory Committee anyway. But we'll let you all know when we meet, and but we'll talk about how we might be able to break this out and just make sure that it's very clear as to what the intended purposes for each of these different calculations. I think that's a good suggestion. So, but I guess, in the meantime, it doesn't sound like there's any concerns over the calculations of the methods. It's more just how we present the results. So I think we can keep, well, Christine is still using these methods.
Yeah.
Anyway, and what we're doing here, we just wanted to get it on paper. So thank you. So the next thing I wanted to touch on today was, I guess, an attempt to try to pull together all of this. And I think the discussion we were just having is an important part of this as well, is how do we use these numbers to make decisions? And really, I think the way I tried to summarize the objective was to maintain a dissolved salt mass in the South Arm that's commensurate to the lake water level and the water volume required for the target salinity range. So there's a lot there. So we have a target salinity range from our matrix that we want to compare with. We know that the overall salt mass that we were just talking about, that's dissolved into the water column, the full depth, the volume weighted salt mass is important because that's what gets mixed in. That's what's transferred back and forth of the North Arm. And certainly the water volume. So if we have a mass, we have a volume that gives us a concentration. So we have all these different variables that we're trying to monitor, that we're trying to consider as we try to manage the salinity that we see in the South Arm. And so, Bill, you made me question whether I'm using paradigms correctly here, but I think as we've discussed this concept of managing the salt mass to arrive at the target salinity, what we see is two different paradigms, and which require different strategies. And I think they're fairly simple differences. Is if we're raising the water, if the water level of the lake is rising, the volume of the water is also increasing. And so if that's happening, we need more salt in the South Arm to be able to stay at the same salinity. If the lake level is dropping and we want to keep it at that same salinity, now we need to actually get rid of salt to the North Arm, because the volume is declining. So that's what this graph is trying to show, is just that, so I think and this is where it comes into trying to forecast lake levels. Are we in a dry cycle where the lake level might be fairly, constant? Or do we think that the lake level might drop? I think that's where, and I think what we were discussing, 45 minutes ago is exactly this, is that if we think the soil moisture levels are low, so we forecast that we think that the inflows to the lake might be low, so the lake level might stay steady or decline. Well, now that gives us an idea of what we need to do with the salt mass if we want to maintain the salinity. So that's really kind of the foundation of, I think, what we've been talking about, and really what we do. So the approach, there's a lot of monitoring that we are already doing, looking at the water level and the salinity in both the North Arm and the South Arm. We're monitoring the flow and the salt flux through the causeway. That's USGS has been measuring those flows as well as with the salinities or the densities, we can estimate what the salt flux. Those are the calculations that Christine was talking about. So then, we went through the exercise today as well as the salinity within the thresholds. So we had a salinities of 118, or what was it? 112. So are we okay? And we are, we're within the salinity ranges that we want to be. So we're looking at the salinity matrix. And for those of you who haven't seen it, this is the simple version. There's a much more complicated version of this as well. But you can see those two ranges, the 120 to 160 in red, and then in the spring, we want to see between 90 and 130 so that the brine shrimp cysts can hatch. We get optimal hatching of brine shrimp. So we can look at, so if we get that upper brine layer value that Christine was just talking about, where, that DWQ is looking at, that's what we want to look at and compare with this matrix. And that tells us kind of where are we? Are we okay? Are we kind of bumping up against where we don't want to be, or bumping down to where we don't want to be? It gives us an idea, a metric to evaluate or assess where the lake is. The next part of the assessment is just what are the trends? And I think this is where the isomass plot that we were just looking at is important, because now we can see, well, where is the salt mass now with respect to the lake level, and what happens if the lake level goes up? If the mass stays the same, we can see that the lake level goes up. The mass stays the same, our salinity is going to drop. And so that's where they get back to that first chart of, if the lake is going up, we need more salt. If the lake is going down, we need less salt. And certainly what Christine is going through to forecast our dissolved salt mass and salinity using the model that they have is a key part of assessing that. And that's what our committee's been doing for some time now, is looking at what is the salinity now, where do we think the salinity might be in 6 months, and then hopefully we can think longer term. So that's where this isomass plot that we were just talking about is. So I think then the next step is, and that we've been talking about is, okay, well, what now? Should we do something? Should we change the berm, or should we put in a more complicated structure that gives us other options? And I don't know that this is the best name for it, but I called it a targeting plot. And really what this is all the information that's in the isomass plot. It's just presented as a little bit different. And I think in terms of, I was thinking in terms of Ben, Ben sees, okay, we're at this lake level, and we know the salt mass. Where do we want to be if I think the lake level is going to go up or down? You can get that if you look at the isomass plot and think through that. But what this is trying to do is just trying to make that a little bit easier, try to provide some targets. So on the left side, you see here is between 88.5 and 92.5. We'd want to try to balance the salt mass at around 900. More specifically, if we're at 4190, we want to be between 760 and 1010. And so, depending on where we are, we typically see a 2 to 3 foot change in water level in a year. Ben can take his crystal ball out, say, I think the lake is going to go down. So if, and I think that's where, today we're at 92.8. We would look over across there and see, well, we want the salt mass to be between 920 and 1200. And I think we are at 873. Which tells us that we're on the low end of that 120 to 160 range. So I don't have here the 90 curve. Perhaps that's something that we should add. Because the left side here of this is 120. That's the 120 target. And here's the 160 target.
And I was going to comment on that. I think that's one important thing is we need to think about the seasonality, I guess, right? Or maybe that doesn't matter, but what the target is, so we know you know, like, we know the lake's gonna drop by the end of summer, and I think it'll put us right about where we wanna be, especially if we're importing salt, so.
Yep. So that's, I think, so I said, you know, with a 2.5 foot drop, that's what we see this year, just as an example. We would want to be between 760 and 1010. So we're at 873. So we're at where we would want to be for the fall. So that's what, you know, search, surely there's got to be a better name than the targeting plot, but that was all I could come up with. But this, I think, helps be able to think about, well, where do we want to be and what should we do? And so then of course the question is if we're not in the range where we want to be, then what should we do? And this is where it goes back to these paradigms, is if we think that the lake is generally going to be increasing, there's a seasonal change that we see, but also I think if we think that we're going to see a longer term shift, that's where we want to try to forecast that, because we know what we can do, you know, with a berm if the lake is declining. But I think when we look at, and I think the exercise we went through with looking at the flow control structure, is that we see importing salt from the North Arm, you know, to raise the salinity of the South Arm. So if the lake is going up long term and we need more salt on the South Arm, that is going to be challenging. It's going to take a lot of finessing of flow through the causeway to be able to do that. And so that's where we want to be thinking, what might we need to do, and you know, in the next few years, because we see it does take time for the salinity of the South Arm to equilibrate to what's happening. So if we're trying to maintain, if we think we're in the right salinity range, you know, the key thing is that we want to try to maintain a net zero salt flux. So if we want to stay the salt mass that we are at, we don't want to be exporting too much. We don't want to be importing too much. So ideally, you know, we're seeing a net zero of what's coming in and what's going out. And I think what I saw was we're currently at about a minus 3.3 million tons per day, where we're still exporting salt to the North Arm because we have the berm in place. And so if we think that the lake is going to be stable at these lake levels, you know, we're still exporting salt, which would be beneficial if we think the lake is going to decline. But if we think that there's a chance that the lake might go up, then, you know, we might want to, you know, get to the net zero to at least be at where we're not exporting too much to the north. So the declining lake level, as I said, is where we've been, and I think we've shown that this is very effective. So we want to export salt to the North Arm, and our net export to the North Arm. So we do that by reducing the import of salt from the North Arm. So our berm did exactly that. We blocked off that deep return flow from the North Arm with the berm. We want to increase the export of salt to the North Arm. So we have done nothing to the upper brine layer, and we're still exporting salt to the North Arm. So there we have a net export because we have very little, and we're starting to see some import from the North Arm, but generally we're seeing a lot of export to the North Arm. And then lastly, we did this as well, as we need to dilute the salt mass in the South Arm. So in 2023, we raised the berm high enough where we essentially temporarily blocked all of the flow through the new breach. That allowed the South Arm water level to artificially go higher than it would have, and it dissolved that, or it diluted that salt mass that was in the South Arm. So I think these are the strategies that we've been implementing, and I think they've achieved exactly what we had hoped. You know, we're right now in a great position with the salinity, especially if the salinity or if the lake level does continue to drop. We are going to be within the desired salinity range. I think the more challenging paradigm is going to be as if the lake is coming back up, because now we need to import salt. We're at 870 million tons of salt in the South Arm, And so if we add more water, that salinity is going to go down. And so we want to increase the import of salt from the North Arm. And that could be done by removing the berm. We know that increases that north to south flow. We've talked about pumping North Arm water over the causeway into the South Arm. So we're directly importing salt from the North Arm that way. We could import salt to the South Arm from other sources. We've talked about diverting that natural runoff from the Newfoundland Basin directly into the South Arm as another source of salt for if and when we need it. We've also talked about flushing sequestered salts and evaporation basins into the South Arm. That's salt's in storage off the lake bed now. But if we needed more salt, that's potentially another source of salt. And obviously there's a lot that goes into these things, but these are just strategies that we can contemplate if we're in these paradigms. And then lastly is reducing the export of salt to the North Arm. And I think this is the most difficult part is, trying to block that upper water column that's flowing to the north. And that's where that flow control structure was trying to find where's that balance point where we can have a gate that can block that flow. And it really needs to be timed carefully with fluctuations in the head differential. So we have a big head differential. If there's a big difference in water levels between the North Arm and the South Arm, it makes it really hard, even if we have a deep gate from the top down, that South Arm is still going to push flow underneath the gate. The gate helps, but we're still going to see flow pushing. But if the lake is where it is now, where we have less than about a half a foot of difference, that's a situation where we can block that flow and have a net import of salt to the South Arm. So those are, there's clearly challenges in doing these things, but I think the hope is that with this salinity management plan, at least it's we're moving the flag forward and saying, okay, here's what we know now, and here's the kinds of strategies that we need to think about. Implementing these things is going to take more work. I think we already have it zeroed in on maintaining desired salinity range. The modeling that we did of the new breach, where we completely removed the berm, we showed that we can actually get it pretty close to net zero salt flux through the causeway if we completely remove the berm. We know that if the lake is going down, we need to push salt to the north. We know how to do that. We've already experimented and proven that. The rising lake level trend, which I think everybody hopes we can do, but that's going to take some more thinking as to how are we going to do that. And I think been looking through some of the past actions in the lake, and when we, back in the 1980s, when they deepened the lakeside breach, they did that because they were concerned about the South Arm getting too fresh, and so they deepened that breach, and we saw a response, but it was short term. We still saw a net export of salt to the North Arm. So because all of our surface water is going into the South Arm, that's the natural thing, is that salt is going to slowly over time move to the North Arm. And even back in the 1960s, they saw that, and their proposals were to try to divert some of the Bear River water through a canal around Promontory Point into the North Arm to try to equalize the water levels better. So these aren't what was, I think Ryan or Scott and Christine looked at some of the stuff I did and asked me some more details, and like, good questions. But looking at, we've tried a lot of these things over the last 50, 60 years, and I think there's a lot that we can learn from. And I think actually where we are today is building on that. So this is all new. Well, I don't know that it's all new, but At least pulling it together is new, and I can certainly send this out to you all to think about. But what I wanted to do is just get your initial feedback on it. Are there any key gaps? But what we're trying to do is trying to get this into a document that then the committee can review, over the next 3 months or so. And then hopefully be able to finalize that so that that can then be wrapped up into the comprehensive management plan that Forestry is working on. So.
Just a couple of quick initial thoughts, but I think that because we don't know if we'll ever have funding to do like any sort of structure that's more sophisticated than the berm, I think the management protocols will have to be kind of flexible. Like either we are, doing the structural thing, or we're seeking the import of salt from Newfoundland Basin, or maybe there's a relationship with Compass that we can work out on some of the pumping, other things, or other ways to even consider using fresh water to dilute North Arm and have it equalized differently. But I do think that another thing that we ought to consider as well is like maybe just when we get into the finer details is considering like the periodicity of the weather patterns and how we think about like 5-year or even 10-year cycles or 13-year cycles or whatever they are. So we can kind of decide like, should we be expecting that we're going to be in a declining situation over the next decade, or where we're at, so then we can make those decisions, because it would take a lot of years. And even with the big, the sophisticated structure, I think we're like talking like that really only works when there's a couple feet ahead difference. So if we're really coming up fast, then like we probably don't have a lot of options, and we should have been thinking about importing salt for probably multiple years in that road. So I think that's like kind of the challenge that I think we'll end up with is I don't want to box us in on a management plan if we don't have money to like do the structure or this other thing. So I think it has to be flexible in like what we have today, and then also trying to seek other solutions like everything that you discussed and have identified.
Jeff, and this is probably too detailed, but the pumping North Arm up and over the causeway to the South Arm, where that would outlet into the South Arm is pretty much in the Bear River bypass to the breach. So, you need to get it further out in the basin. It would just be a continuous loop, I think. But I got a detail, but that's just, you kind of want to get it past that.
And maybe around Fremont or something. Right?
Yeah, you could use a canal.
Yeah.
Pump in the canal.
I think your point is very well taken. We don't have specific. This isn't a tactical plan. Say this is what we're going to do. I think understanding what the strategies are. We could leave it just at the numbers without the bullet points. If we think the lake is going to go up, then these are the 3 things that we need to be thinking about how to do. And then.
So one other thing I noticed that maybe was just missing that graphically we need to represent is the state of the law as it relates to like the floor for the berm. Like we have to raise it at 41 if it drops below 90. So like that's going to be something that no matter what we do, the losses we have to raise the berm. Yeah, I don't know. Other than that, I don't think there's much else. I think we'll have to also. One thing I'd like to see in the plan long term, and I know that we're going to go into this detail, but like, what are the things that we need to be measuring and monitoring in order to achieve like being able to predict and forecast these things? Because like Christine and wildlife and a lot of other folks do that. UGS does that monitoring, and so collectively, how do we keep supporting them to be able to do that and not like lose out on a contract one day and then this whole thing goes to the wayside because we don't have the information. So identifying those up front, I think would be nice in a plan, so we know. Make sure the legislature keeps giving us budget for those things.
Bill.
Yeah, I just want to make sure that we don't overemphasize this scenario of needing to import salt during a rising lake level. Because we know, based on experience, that the chances of the lake coming up in the next few years is low, given the periodicity. And so I think, Ben, you're right to bring up the periodicity. The likely scenario, the very likely scenario, is the lake continues to decline over the next several years until we get the next wet period. And by the end of this dry period, it's going to be relatively concentrated. And so I think that this rising lake level trend importing salt scenario is an unlikely scenario, given the history. And we have to acknowledge that and make sure we don't overemphasize it, because we don't want to be asking for resources for something that is unlikely to occur. We do want to acknowledge a contingency, but, you know, be realistic about its likelihood.
Bill, that you articulated that a lot better than me, but I think that you're right. Like the 80s probably aren't going to happen again, right? Like we had a really good year and the lake came up way less than I think everybody expected, especially given the fact that it was segmented. And so I don't know that we'll ever see those kind of rises again either. I think that was a kind of a little bit of an anomaly or a fluke. And if that happened, things would probably regulate as well. Like we'd be able to, I think there's ways that it would get figured out, but I think that if we were operating in the, trying to stay in that salt mass and we would make those calculations and decide what the mass that we need to bring back each year, I think we could still stay within that, even if it, you know, you have a few good years. I don't think it would necessarily be necessary to do anything drastic, right? Like I think that's going to be where we have to make this decision about like a $40 million structure versus do we go out and try to use that same type of funding for, you know, restoration or water leasing or, you know, water purchases. I mean, I think there's things that perhaps could have a stronger impact or be more necessary, right? But anyway.
Yeah, I think there's balancing that reality with, you know, attempts to get more water to the lake. As we're trying to get more water to the lake, that would imply, you know, we're making big investments to do that to cause the lake to rise. So I think Hannah's we'll have to work closely just in terms of how do we message this in a way that, you know, we need to be realistic, but also be consistent and not conflicting with messaging.
So I think that this is another thing that, like, obviously it needs to be refined, but I think that this would be another great place where it'd be really cool if the Salinity Committee could kind of adopt a protocol that, you know, I don't know how prescriptive we can get in this, but I think having the, you know, the kind of like, here's how we determine when we need to raise, lower the berm or what other protocols we can take when we want to import or export salt. And then we still, I think, I don't really perceive this body like ever going away, because I think this is still going to have to take some decision making and some like recommendations from people who understand those things. And I don't think it's going to be like this calculus where we have a prescriptive way that we get to do this every year. And when it happens, because there's so many variables. So I think that we'll have to refine this, but I think at the end of the day, it's going to be more of like a kind of like a recommendation of the Salinity Committee or a prescription of like when we need to decide what those things are. And it may be a lot of the time that it's okay the way it is. Like right now, we've been in the same spot with the breach and haven't had to do anything for now like 2.5 years, I guess, or so, maybe 2 years. But anyway, that may be that we just hit the sweet spot and where we can continue on that way until something big happens. But that's how I kind of envision this management plan. It's like, what does the law say? When should we be discussing this and making recommendations? And what should we be discussing? Is it importing or exporting? And then this body will make that formal recommendation still.
Great. Thanks. Any other questions or comments?
I think thinking about this importing salt is actually kind of a neat thought experiment, because I think you're right. If the target is to raise lake elevations and we sort of sustain a higher elevation in the South Farm, then it can become a bit of a challenge to get salt back. And we don't quite understand the lags. We don't quite understand the magnitude of mass that could be transported via these other sources like Newfoundland Basin or salt from evaporative ponds. So I think it's important to think about just like how feasible are each of these options, and then what is the time lag or the time thinking about it ahead of time to say, if we really needed salt, you probably need to, because it has to be just the right conditions. You might need to be thinking about it 6 or 12 months in advance. And yeah, it is likely the lake is going to go down.
Or
It
like
seems
even a year or 2
Yes,
years in advance.
right,
you gotta
because
start
it's such
thinking
a
about what's
slow
gonna happen.
ratcheting. And then even when you do get salt back, it's sequestered. And so then it's mixing back into the upper brine. So I agree that it's likely that the foreseeable future is probably a stable or declining lake elevation. But I do think it's really important to think about this because we haven't quite figured this part out. We figured out how to export salt
And
quite well, but this.
And that's exactly, I think that you said, again, you all of these smart folks articulate your words a lot better than me, but I think because it's so much harder to bring salt back, I think that's actually why we, like right now, I think that's why it's okay to just leave it open and allow the salt to get, or like allow for that salt mass to return back to the south arm. Because we know that if we get to a point where we have to do that in the spring, we can always raise it up and just export salt.
We can do that really well. We've
But
demonstrated.
yeah, but we can't always bring it back. So I think erring on the side of being like maybe a little bit in the higher end of the salt mass spectrum, knowing that we have the ability within 6 to 9 months to always regulate that and export quite a bit. So that might be another thing that maybe we need to preference some things in like how we decide where we want to be within that spectrum. It's not the periodicity or the modeling for the next few years or however we do that.
I have a really stupid comment and I'm gonna be embarrassed and leave after I. But could we do like a penstock structure on the north side of the lake? Where north water can flow down into that penstock? Can we tunnel underneath the railroad causeway and have a non-corrosive pipe that would, move water to the south side of the causeway?
Yeah, I think it's possible. I think the challenge was how do you control that flow? But if you had a penstock or an intake like you might have on a big reservoir, you're pulling water off the surface and it's dropping down. So potentially,
Can you have a structure control the openings on the penstock? Close it off. We're not worried about moving water from north to south. That could withstand the slope.
right?
Right, I think
That's a site that could cost $100 million.
Yeah, I was gonna say, I think that one of the challenges, we looked at that, right? Like we looked at siphons and culverts and other control structures. And I think that the challenge was that the volume that you would need to be able to make that work was the limiting factor because you'd have to have like a bunch of penstocks to make that work. And then all of a sudden having a structure that bores under and has control structures that are non-corrosive, then we're into that $40 million thing again. And it's also limited to the head difference of like 2 feet. Like you're not going to be able to do anything outside of that. So the times that you can use it are also limited. So I think I think that's where we started, where like things like that, ideas that would do that. And then where it evolves, like, damn, everything is like 4 times more expensive than we thought it would be, or more. So I don't know, but I think that's a cool idea.
A lot of myself, so I'm gonna stay.
The penstock is like where you really nailed it, right?
Yeah, no, I mean, I don't think we've talked about separate structure, intake structure with a weir that would allow north arm flow to drop. We looked at siphons, we looked at culverts, we looked at a lot of those things, but it was, the culverts or those pipelines have a limited capacity. So what's the benefit cost of these things? So anyway, those are great comments. So I think what we're at noon here, I think what I'll do is I'll try to incorporate these things into a draft document that you'll hopefully see here in the coming weeks. And then I think when we get it, love for you to review that and provide comments, questions. I think questions are fantastic because they help improve it. And then with the idea that we can hopefully move to a final sometime this fall. So I think we've got time. I think we've been implementing these strategies already. So it's just a matter of trying to get them on paper. And so we've got a kind of a new benchmark that we can work on. So, any other questions or issues or I guess suggestions for future meetings? I think Joe had a great suggestion on water forecasting. Anything else? If not, is entertained a motion to adjourn.
So move.
All right. I don't think we need to vote. Thanks, everybody.
Sorry, Christina.
No.
I think I misunderstood your.
No, it's okay. I missed the whole point.
Yeah.
Great. Yeah.
Yeah.
You're welcome. I'm glad that it's good start.
I think it's exactly, I mean, it's like directly into this, like that. Something that we can use as value where we can make decisions on.
Yeah.
And like, get rid of this quantity.
Yeah.
This isomass business.
Yeah, that's gives me so much joy. We're doing it.
Yeah, no, it's cool. I think it's so cool. The fact that we're getting 17.
This is so fun to work on. Yeah, so we'll meet, Jeff, like kind of a subgroup and just refine this.
Yes.
You want to schedule that, Jeff?
Okay.
Jeff, do you want me to schedule that or do you want to schedule it?
If you want to.
I had that work group put together. So I'll just reach out to them. And figure out a date. When's your next stack?
Oh, shoot. I go to September.
Yeah.